Hey guys, this is Mrs. Walker, and today's lesson is going to be about the moon and its effect on tides here on Earth. Typically, I would take you guys down to the bay to do this lesson because it's really fun to see the different species that take advantage of things like low tide, little crustaceans and whatnot, bugs, shrimp, birds that take advantage of low tide in our area. So if you live close to a body of water, I'd encourage you guys to go out at low tide and see the difference between that and later on in the day. So firstly, what is a tide? A tide is a laundry detergent, teacher jokes, and a tide is the change in average depth of water in large bodies. So what I mean by a large body is like an ocean, a bay, a very large lake, not things that are small like streams. Of course, we can have tidal changes in rivers. That's why, especially if we're going to get a whole lot of rain, that high tide can be a little bit dangerous in our river systems local to the area because it can cause some localized flooding. So there is usually a high and low tide per day, depending on where you're at on the planet. This is not always, especially when we go much further up north, but we do have changes in most places 2 times a day, and that is a high tide and a low tide. Now, I'm going to talk to you guys about 2 specific kinds of tides, known as the spring tide and the neap tide. Let me first explain to you what's happening here in the diagrams. The moon has a gravitational pull that is strong enough to pull on water on the planet. It's strong enough to move liquids. It's not strong enough to move rock. However, the Earth and the moon hold each other into place. We have a pull on the moon, but the moon has a pull on us as well. So it's kind of like tug of war, but Earth is definitely the winner, on field day. So, but what happens in tides is that, especially during something like our spring tides, you're going to have the largest ranges because the sun, the moon, and the earth form a straight line. And that straight line is going to cause the highest amount of pull on our water, and it's going to cause a very high tide in some places on the planet. That high tide is called, it's where water bulges to one side of the planet. So some of that water that was maybe on the other side, it pulls to this side as a bulge, and it causes a high tide there. Now the opposite of this is a neap tide. Neap tide's over here. And during a neap tide, the sun, the earth, and the moon actually, they form a 90-degree angle. And because of that, the sun and the moon are not working together to pull on that water. And because of that, there's going to be a very low change in the tidal ranges during the day in that average. So during a neap tide, the gravitational pull is kind of split. It's definitely weakened, bugs, or lessened as you go through. Now, what causes a tidal cycle in general? Well, what causes these is because of the fact that the Earth is actually spinning faster than the moon is. Because the Earth is spinning faster, it means different parts of the Earth's face are facing the moon at different times. So the moon is almost trying to catch up with that water, and because of that, the water will continue to move. If this didn't happen and the same face always faced the moon during our orbit, then water would just remain in one constant, like say high tide. It wouldn't pull back. This would have a huge effect on lots of different things, from convection currents. Of course, waves would operate quite differently. So the effect on tides on our planet is very, very significant. Winds would probably be somewhat different because of how they move over that water as it comes in and out. So our tides are incredibly important. Now I do want to talk to you guys really quickly about the myth of the full moon. When teachers and parents, they look at each other and they're like, is it a full moon? And what they usually mean is the kids have gone crazy. Well, there's a little bit of science to this, in that we are made of water as people, and because of the fact that we're made of water, we can have changes to our physical selves as a result of the moon as well, especially in our heads. So when people used to talk about people getting kind of crazy around the full moon, it's because there is a little bit of science to that, because the gravitational pull of the moon while it's full is greater, and as a result of that, sometimes it can feel like it's pulling on us a little bit as well. I don't believe the myth of the full moon with kids, and I try to not say it, but I do have a shirt that says it on it, and I wore it to NASA, and lots of other teachers kind of like fist bumped. They were like, hey, that's a good shirt. I was like, yeah, it is a good shirt. I couldn't find it for today, but anyway, so I did want to talk about the myth of the full moon, werewolves aside. Anyway, I hope you guys all are well. Listen up for the assignment. What you guys are going to be doing with this particular information is you will be copying the page in your ISN, and then after that I have a diagram that shows both a spring and a neap tide. You're going to diagram the high and low tide and tell me which one is which, along with 180-degree symbol and our 90-degree symbol, and I'll know which one you're talking about. Hope you guys are well. Make sure to wash your hands, get outside when you can, and I'll see you guys in the next one. Bye-bye. See my board. There's the dog. Again, let me kind of move that up a little bit. Okay, so first of all, guys, a tide. It didn't hit me in the head. It's fine. This is fine. We're going to go with take one. Bye-bye.